The next exciting part, the Diamond Jubilee lecture by Professor P.V. Vara on innovations for addressing food, nutrition, climate, and soil security. And before we proceed, let's have a brief profile of the speaker. Professor Varaprasad is an alumnus of our own university who obtained his BSc Agriculture degree in 1991 and MSc Agriculture in 1993. He received doctoral degree in the University of Reading, United Kingdom in the year 1991. He moved to Kansas State University in 2005, where he is currently serving as University Distinguished Professor and Director of Feed the Future Climate Resilient Sustainable Intensification Innovation Lab. Dr. Prasad's research focuses on understanding responses of crops to changing environments and developing best management strategies for enhanced and sustainable yields. He is passionate about human and institutional capacity building. He has established active research, education, and outreach programs in 14 different countries around the world. Dr. Prasad's publication record is exemplary, with over 425 journal articles, 55 book chapters, and 5 edited books. His research has been cited over 35,000 times with an H index of 95. For the last 3 years, he has been listed in the top 1% of highly cited and influential scholars around the world. In 2014, he created history at Kansas State University by receiving the largest single federal grant of $50 million. Similarly, he received another $50 million in the year 2024. Dr. Prasad has trained more than 250 students and visiting scholars from over 15 countries, received over 50 awards and recognitions from multiple national and international organizations. He is a fellow of 3 prestigious organizations in the United States, which are American Society of Agronomy, Crop Science Society of America, and American Association for the Advancement of Science. He is a former president of Crop Science Society of America, being the first Indian origin person to serve in that role. Very recently, he was elected to serve as the president of the Council of Agriculture, Science and Technology, a US organization which communicates science-based solutions to all scholars and policymakers. With this, I proudly invite our beloved alumnus, Professor P.V. Varaprasad, to deliver the Diamond Jubilee lecture.
Good morning, namaskar, and thank you very much for that kind introduction. First, I would like to thank the organizers of this Diamond Jubilee celebration of my alumni, Professor Rajendranagar, for inviting me for this special event. And I also would like to thank Dr. Rajendranagar, the former Vice Chancellor of this university, and Dr. Rajendranagar, the current Vice Chancellor of the Horticulture University. This is a very special moment for me, because it's after 30 years I come back to my alumni to speak to you or share my life experiences with you. Not only that, but also it's the first time my parents are here with me. So I would like to start with our Sanatana Dharma saying, Matru Devo Bhava, Pitru Devo Bhava, Acharya Devo Bhava, and Atiti Devo Bhava. There are people in our life who give up their dreams so that we are successful. And many of those are here with me today. My dad served in Indian Air Force, a proud ex-serviceman for 26 years. Let's give a round of applause for that. My mom, proud housewife, and my sister, proud housewife, they're all here. And the rest of the family is there on the photo, my wife, my 2 children, and Bhavagaru and Tanvi. And there are people in our lives who change our life the way we think. And that is Acharya Devo Bhava. And I would like to thank my mentors or advisors, V. Satyanarayana, Dr. Poddar, and Dr. Muralidhar, and teachers who have changed our vision. And at least one of them I see in front of me, Dr. Chandrasekhar Rao, Dr. Praveen Rao, and Dr. V.R.K. Murthy, I got my first paper, first publication was with Dr. P.C. Rao garu. Thank you. And of course, we wouldn't be here without our friends who have been there in good times, hard times, fun times, and the times which we cannot often share. And that's the reason why we are here, to celebrate this great memories of this institution which created life for us. And many of them are shown in this visual here. And I know I can see some of them here, but if I start naming them, I'll miss a lot of them. But I would like to say thank you to all of those 1987 batch entry, and then 1991 master's degree entry. Thank you very much for all you did. And today we are here to celebrate those memories. And I want to congratulate each one of you for selecting agricultural science as your career. Because we always say that medical profession is a noble profession. But I would say to each one of you that agriculture is more noble than medical sciences because we are the one who provide food to everyone, not only humans, but every living being on this planet. So welcome to the science which is going to transform the agri-food system and feed the world for the rest of the time. Thank you for choosing agriculture. And we need to change. I would request Dr. Janegaru, and this is the time to change the way we see agriculture. Those days are gone when agriculture was seen to be hard work, risky. But we need to see that agriculture is food. Agriculture is nutrition. Agriculture is health. Agriculture is technology. And agriculture is business. And with that in mind, I'm sure that you will be successful in whatever you do in your life. So that's a key message which I wanted to give you. Now, the other part, science part now. So this is going to be my outline of my presentation. I've started my timer already, so I will make sure that I'll finish it on time. First, I would like to talk about the long history of Kansas State University with this university and the previous successor of this universities. Then I'll introduce you to some of the global challenges and the need for innovation. Dr. Srinivasan kindly already set the stage for how do you define agri-food systems and importance of climate change and what are some of the other challenges. And then I will provide you the current status of sustainable development goals, and then hidden costs of agri-food systems, and then introduce to a systems platform called Sustainable Agricultural Intensification and how it can address the global challenges, a brief overview of my innovation lab, and then give you 17 selected examples which are ready to be scaled and can actually address the global challenges, and I'll conclude. There's a long history of Kansas State University and this university. Kansas State University is the first land-grant university established in 1863 after the Morrill Act was signed. And then it took the lead of establishing the land-grant system in India, beginning with our own alma mater, the previous versions of it, Andhra Pradesh Agriculture University. And Kansas State University has one of the top agricultural colleges in the top 5, mostly on top 5 most of the time. Let's now talk about the global challenges which we have. 828 million people do not have access to food. It is unacceptable. 2 billion people are malnourished, both undernourishment and overnourishment, which is also unacceptable. Climate security is a big issue. Dr. Srinivasan mentioned that this year, 2024, will go down in the history as the warmest year, where we have reached the temperatures of 1.5 degrees Celsius since the beginning of last century, and that is not going to change unless we change ourselves. Water security with prolonged drought and limited water and rapid flooding is a serious issue. Soil security, soils are degrading rapidly and soil health is being lost. Energy security, we have high demand for energy and there is a need for renewables. And then, most importantly, equity and equality is a serious issue. These resources are not available equally, particularly to women and youth, which needs to be changed. Now, the status of Sustainable Development Goals. Before these were the Millennium Development Goals. We could not meet them. We started again in 2015, Sustainable Development Goals, and said that by 2030 we'll meet them. Last year we're halfway through, and only 15% of those are on track. That means 85% are not achievable in the target unless we change that scenario significantly moving forwards. So there is new investments urgently needed in our agri-food systems. This is the relative yield gain of major food crops. In 60s, we were having annual yield gains about more than 3% a year. But that number significantly decreased in the recent decades. And we say that we need to improve the food production by 60% to meet the 10 billion people by 2050. So that trend has to be reversed, and we need to be going back to that 3% per year increase. And there we have innovations in breeding, genomics, phenomics, artificial intelligence, which will actually allow us to meet those goals. Dr. Srinivasan mentioned about the agri-food systems, and this report came out last year, December 2023, which talks about the hidden costs of agri-food systems. $12.7 trillion. I can't even put my head around that number. But most significantly, what it is 73% of that is associated with health, 22% with environment, 4% with social. And of the health, majority of it is associated with diet and nutrition, which is in our control, and our agri-food systems can actually help change that trajectory. And when it comes to environment, it is related to nitrogen, climate, water use, and 4% of the social is associated with poverty or social well-being. So that needs to be addressed significantly, and that can be done through innovations and technologies which can enhance nutrition, health, and improve resource use efficiencies. Agri-food systems contributes to climate change greenhouse gas emissions. There are numbers which float anywhere from 20 to 30%, but that is in its current form. If we adopt new innovations and with a focus on adaptation, mitigation, and resilience, and sustainable intensification practices, combined with novel technologies, we can actually negate these greenhouse gas emissions. And agriculture is the only system which can be net carbon negative. All other sectors which contribute to greenhouse gas emissions, energy, transport, everything else, can become net zero or can be neutral, but they cannot be net negative. Agriculture is the only sector which can become net carbon negatives because of soil carbon sequestration and terrestrial sequestration. Now, the introduction to the sustainable ag intensification, what does it mean? The goal is to provide access to safe, nutritious, and healthy food at all times to all people from existing farmland without damaging our ecosystems and natural resources. And I would like to redefine that a little bit, because we have done so much damage already that doing no harm anymore is not going to be helpful. We need to be thinking about regenerating our natural resources, rebuilding our society. So regenerative agriculture using nature-positive solutions has to be at the core of these innovations. And it has many components to it: the genetic intensification, agroecological intensification, and socioeconomic intensification. Genetic intensification meaning that breaking the yield barriers, resistance to pests and diseases, tolerance to abiotic stresses, focusing on improved nutrition and health. And agroecological intensification focuses on diversification, farming systems, integrated soil, nutrient, crop, water, and pest management practices. And socioeconomic intensification is developing new markets, building social capital, creating sustainable livelihoods, enabling environment through policies, and also human and institutional capacity building are at the core of this. And we have many new tools, genomic tools, geospatial tools, artificial intelligence, nanotechnology, mechanization, precision agricultural, robotics, and microbiome, and public and private sector, which needs to be encompasses all these three components. Basically, what it gives you is genotype by environment, by management, by social interaction. G by E by M by S, which is very critical. And that will require a systems approach to address those challenges. So now, a brief overview of my innovation lab. It is called Sustainable Agricultural Intensification Innovation Lab. We work in 14 different countries around the world, spread from Asia to East Africa to West Africa to Latin America and Caribbean. I don't have time to speak to that details of our innovation lab, but I will request each one of you, to those who are interested, to visit our website and get more details. But in brief, we have in each of those countries, we have a research, outreach, and education program. And we have a mechanization consortium. We have 4 consortiums: mechanization, digital agriculture, policy, and soils. And then we have 4 centers of excellence, 1 in Cambodia, 1 in West Africa, 1 in Haiti, another 1 in Guatemala. So it's truly a transdisciplinary research program. We have about 120 scientists, 130 organizations, including 20 US universities, 9 CGIAR centers, and more than 300 students have been trained with master's and PhD degrees. And we have influenced more than 50,000 farming communities. That was in the last 10 years. And now moving forward, we are more focused on the climate resilience piece. It's a new innovation lab, another $50 million, focused on 8 countries. And the goal here to empower people and institutions with knowledge and innovations that positively impact agricultural productivity, environment, and natural resources. And we have identified 6 key areas, including digital agriculture and ecological intensification and circular bioeconomy principles. And those of you who are interested to learn more, please visit our website as we move forward. So now, a rapid fire. I'm at 12-minute mark, so I have about 20 minutes, and I want to give you 17 different innovations. So I won't give details, but just an overview. Those of you who are interested to learn more, please let me know. So 17 different innovations to address food, nutrition, climate, and soil security. And I will give you a diversity of these innovations coming from different agroecological regions of the world. And then most of these are relevant to conditions of India, and particularly for our states of Telangana and Andhra Pradesh as well. So, but of course, local redesign is necessary. So those of you, especially the students, I hope that I'll give you enough information so that you will get excited that you have a bright future ahead of you, because there are a lot of global challenges, but also there are many solutions. And of course, they needs to be redesigned to meet our local needs. And some of these examples are from literature, and I've given you the source of information for that. So let's start with number 1, speed breeding. Traditional breeding takes about 10 to 12 years to come up with a new hybrid or variety, which is not necessary and these nowadays. So we have done shuttle breeding. Next step, different locations, maybe 2 generations per year. Now we have something called speed breeding, where you control environments with lights and temperature. You can speed up the generation, so you can get about maybe 6 generations per year. So you can bring that down from 12 years to 2 years to release a variety. So that's number 1. Number 2 is CRISPR-Cas technologies. We have the gene editing tools in non-GMO process. I want to reiterate, it is a non-GMO process. So we can edit the genes, CRISPR-Cas with CRISPR-Cas9 cassette, so that we can target the things which you wanted to do. And you combine that CRISPR-Cas technology with speed breeding, that is what is called as express edit technology. So you can not only influence the gene or edit the gene which you needed, but also speed breeding so that you can generate those varieties faster. So that innovation needs to be combined. And now you have predictive modelings to help us do that as well. Number 3, crops targeted for crop farming systems. We are growing crops in regions which are not suitable for those crops. That's why our productivity is low. We are degrading our natural resources, using a lot more water. So we need to identify crops targeted based on your farming systems. Globally, there have been 72 farming systems identified based on biophysical and socioeconomic conditions. So we need to identify those, and then suitable crops should be grown on those hydroecologies. One simple example here is the temperature response curve for the majority of the food grain crops, which I spent my early career developing these curves. Each of these crops have a different cardinal temperatures: base temperature, optimum temperature, and ceiling temperature. So each crop has a different ceiling temperature. Among the cereals, millet is the most heat-tolerant crop, followed by sorghum, followed by maize, followed by rice in terms of sensitivity. From the legumes, beans is most sensitive, peanut is more tolerant of groundnuts, cowpea, mung bean, and you have green gram and black gram as well. So we need to identify suitable crops which should be grown on those particular farming systems. Third, that was the third one. The fourth is we have many climate resilient and nutritious crops. International Year of Millets 2023. We have the director of IIMR here, Dr. Tara Satyavati, who took the lead and organized many activities. So millet is not just one crop, it's a 17 different crop species, and they have large genetic diversity, very high nutritious value, low inputs, and then low carbon footprint as well. So we need to be identifying those and promote these millets as we move forward. But to promote them, we need to be focusing on market opportunities, new market opportunities, both domestic and international, appropriate policies, and also support price, which is very important. That's available for the other cereals, but not for millets appropriately. That's to be needed. The fifth one is, I talked about the 75% of the $12 trillion basically associated with health. So we need to be focusing on biofortified crops and varieties. Thanks to Harvest Plus, we have many of these variety crops already available: high iron beans, cowpeas, lentils, millet, high zinc wheat, rice, maize, and sorghum, high vitamin A sweet potatoes, cassava, maize, and banana and plantains. And many of these varieties are available, so we need to be scaled up. And the challenge is to quantify the bioavailability. It is available in the grain, but is it available when we eat? So bioavailability needs to be there, and health outcomes needs to be quantified, whether it's actually helping remove the malnutrition, and a suitable agronomy for those climates should be addressed. There are many stresses in our agri-food systems, abiotic and biotic stresses. And among the abiotic stresses, drought and heat and salinity and flooding are the major ones. And this is a program called DTMA maize, Drought Tolerant Maize for Africa. Started in 2014, started in 2004, first phase finished in 2014, second phase continuing with stress tolerant maize for Africa. 13 countries of maize which contribute to 72% of the production, 184 varieties, each of them producing 50% more grain yield, and no impact or no negative impacts under normal conditions. So we should be making sure that seeds of these are available, high quality seeds available on time, in sufficient quantities for farmers to be using to make a difference in their livelihoods. Number 7, doubled up legume systems. We all know about intercropping, growing 2 crops in a particular configuration, that is a cereal or a legume. But here I'm proposing 3 crops. You have a cereal, which could be maize, sorghum, or millet, and you have pigeon pea, which is a perennial legume. And then underneath the canopy, because pigeon pea is very tall, underneath the canopy of the pigeon pea, you can actually grow some short height legumes such as groundnuts, cowpea, beans, or mung beans. So that you can take advantages of both below ground diversity, above ground diversity. So that's a doubled up legume system which intensifies your program, and you need to identify suitable varieties and actual configurations needed to address or will fit into your local farming systems. Number 8, dual purpose crops. There are no farmers around the world who only produce one crop. Every farmer has multiple crops, and they also go beyond crops, livestock, either cattle, swine, poultry, aquaculture. So there's always multiple demands from that. So we need to be focusing on crops where grain is for human consumption, biomass is for livestock, because we need to be taking care of them both. That's what is called as dual purpose crops, and we have developed dual purpose crops of sorghum, pearl millet, and cowpea. Not only that, we also biofortified them. It's high zinc and high iron, so that when you feed the biomass of the cattle, it's also nutritious. And we need to be understanding, again, the bioavailability of these crops. Number 9, agroforestry systems. And this is very suitable for the semi-arid tropics. It is so that you can actually take advantage of everything around it. This picture was taken on Senegal. On your left is a tree which is naked. There is no leaves on it. And there's a peak farming systems time, or crop production time. That means it has reverse phenology, meaning that it is not competing with your annual crop during the peak season. Whereas in the off season, this is the only tree which will have all the leaves, and livestock will come and sit underneath it, fertilize the soils, and it also has thing called hydraulic lift. It removes the water or moves the water from the below layers to the above layers, so that it's available to the crop. We have tree systems. We also have this is Acacia, Phiderbia albida tree, and we also have shrubs, which is Angera senegalensis and Piliostigma. So we need to be identifying these type of crops which can be suitable in your own local farming systems. Moving along, I know I'm going fast, but if anyone of you would like to have more details, please reach out. Number 10, perennial grains. You may say, why am I saying perennial grains? Because, we changed our perennials to annuals over the last 100 years. Sorghum and millet both are great examples of that. Sorghum is by nature a perennial. We made them annual. And now I'm talking about going back to the perennials because we need to make sure that we conserve our natural resources. We need root biomass in the soil to improve the soil health. So using perennials, I'm not saying that perennials are fit for all the places. It has a perfect niche in the marginal areas where you can actually use these crops. And successful example is perennial rice. Perennial rice was the innovation of the year by AAAS Science magazine, this 2022. And 8 harvests or 8 cuts, similar yields, no negative impacts. So that's one example. And we have Konza, perennial intermediate wheat grass. Konza is another example. And there's also working on perennial sorghum. So I'm pretty confident that moving forward in the next 2 to 3 years or next decade, there'll be a lot of these varieties. Again, they're never going to replace our annual systems. I want to reiterate that. It's not going to replace our annuals. There is a niche area, because again, as I said, we are growing crops where we should not be growing those crops. So there is a space for perennial crops in our systems. Number 11, conservation agriculture practices. We are all aware of those 3 principles: no tillage, continuous soil cover, and crop rotations. And that principle needs to be used in all farming systems. You know what's happening in Uttar Pradesh and Punjab, and the residue burning and all the pollution. So there is a space for that. I know it has some limitations, like mechanization and herbicide technologies, but those are available. Using those conservation agriculture principles and combining with them drip irrigation system or micro irrigation system. We have done that in the smallholder farmers, where we are using locally available mulch, using the solar powered drip irrigation system to irrigate, and farmers are actually fetching a lot more yields, and which has been very beneficial for them. Number 12, pesticide use is rampant. We need to make sure, it is difficult to control pests and diseases, but there are alternative ways, or at least integrated pest management, where you can use a combination of chemical and non-chemical fertilizers, so not chemical products, so that you can address those needs. This example is called push and pull technologies. So maize is your main crop in the thing, and it is intercropped with a legume called desmodium. It produces volatiles which repels the pest, in this case stem borer, and on the borders you grow Napier grass which attracts those stem borers. So it's called push and pull technologies, and that's been very successful in lots of places, and this is just one example. I want every one of you to focus and find these type of species, and not just one crop but multiple crops, so that you can address. And again, it's an integrated pest management. Doing this alone is not going to be helpful. At least you can minimize the pesticide use, and then you can save our environment. Number 13, digital tools and site-specific management. This is going to be the innovation, because we have now 3 different levels of image taking: satellite imaging, drone imaging, and ground imaging. And if you can combine these 3, you can have a pretty good digital map of your area, and you can use those tools to identify site-specific management of seeds, nutrients, irrigation, pesticides, herbicides. And there is a tremendous opportunity. This is an example of space to place of IFDC, where they are trying to provide prescriptions for smallholder farmers to address those issues. And going along those lines of digital and artificial intelligence and data collection, now you have innovations or technologies which can provide zone mapping of your areas, of your field. And these technologies are scale neutral. Again, I repeat, these technologies are scale neutral, meaning that they can be used by larger farms, medium farms, and also small farms. So that's what we are looking for. So once you have the digital map, whether it is nutrients, water, weeds, then you can use site-specific management using variable rate application. Because now we are blanketly applying the seeds, blanketly applying irrigation, blanketly applying fertilizer, blanketly applying the pesticides and herbicides, same throughout the field. But we all know each foot, each square meter in the field is different. So we are wasting a lot of resources, and we are creating a lot of environmental damage. So by using this combination, you can have variable rate application of these various inputs, which will decrease the cost of application, increase the input use efficiency, and save our environment as well. And the 15th example is on pests and disease monitoring system. Here is an example where you can take a digital image of your pests. It's get pests or disease or symptoms actually, and it goes into the cloud, and it matches up and sees that which is the disease, or which is a pest, or which is a nutrition, which nutrient is limiting, and it provides you a site-specific prescription. And this is just one example of Planix, which can be used, is available for use. This is a very good pest diagnostic system, but it can also be used for any other type of stresses, by nutrient stress, or also water stress, or other stresses. And the last 2 innovations is going to be the microbiome and microbials and biomolecules. Dr. Srinivasan talked about the broader One Health. So, One Health at this point of time only covers human health, animal health, and environmental health or ecosystem health. It's missing the 2 most important pieces: soil health and plant health. Without appropriate soil health, you cannot have plant health. Without that, you cannot have animal health. Without those 3, you cannot have human health. If you don't have all of those 4 health, you will not have ecosystem health. So let's all be the proponent of broader One Health. And microbiome, microbials, and biomolecules have a significant role to play to manage many of these stresses, and there's a lot of information on that. Second last example, I know I'm at 28 and a half minutes, so 2 minutes, I'll wrap it up. Nanotechnology. It'll play a significant role in multiple components, particularly these 4 areas: stress sensing, stress tolerance, stress protection, and precision delivery of those inputs, whatever it is. Because now you can have micro sensors which you can put it on the leaves, you can put it on the soil, you can put it on the stem, or you can put it in the roots. It'll tell you whether the plant is stressed or not. If it is, what type of stress it is. So that's the technology, nanotechnology which is available. Once you identify that stress, you can actually apply nanoparticles to manage or tolerate, so that plants can tolerate that stress. And secondly, if you know that stress is coming, then you can actually manage it prior to that, so that you can protect your crops from the stress. And then precision delivery of fertilizers, precision delivery of nutrients, pesticides. One example is nanourea, but there is more research needs to be done on that. So those are the technologies which we have. And the last one is cross-cutting, social innovations. I want to emphasize this and take a minute to explain why this is important. Let's reflect back. There are many innovations, including your own PJTIU. I believe you have many innovations, many technologies, and most of them fall in the valley of death, and farmers never see them on their field, right? So we need to be making sure that the technologies are transferred. I should not use the word transfer. This is the part of the training which we need to give to the students. It's never a transfer of technology, because when you say transfer of technology, you are separating people. One who develops the technology, one who takes the technology, one who delivers the technology, and one who uses the technology. And that's a linear model of technology transfer. It has not worked, and it will never work. It has to be participatory approaches needs to be taken into consideration. So that's where the social innovations is required. That means understanding the needs of the farmers. Farmers should be at the front of the research program, not at the back of the research program. I'm emphasizing this for the students. Farmers should be integral part of your research before you start your research. When you are diagnosing, when you do the literature review, what do? You do to the scientific literature, journals, find out what's the gap, but is that what you need? You need to be talking to the farmers. Go to the farmers. Instead of going to the literature, go to the farmers and ask them what do they need. And then go back to your professor and then look into the literature and say what is known, what is not known, identify the gap, develop your hypothesis, develop your objectives, develop your methods, and do the experiment. And if it doesn't work, go back and redo that process again. So farmers at the front of your decision making. That also goes for our institute directors and our leaders that understand the needs of the farmers, so that your ultimate goal is to help farmers. So there are several innovations which have happened. Farmers' Food Schools, Women's Self-Help Group, and now we have many knowledge-sharing platforms, including the WhatsApp and including the AI tools and chat GPTs. And we need to target our audiences with an appropriate technology. And soon to be farmer chat is already available, I think, the digital green, and there's a lot of those opportunities as we move forward. And I would like to end it now, but keep this in mind, because I will repeat again. A technology is not a technology if it is not adopted. Read my lips. Technology is not a technology if it is not adopted by the people who need it. With that, I would like to conclude and give you a summary of over the last 32 minutes. Hopefully I've convinced you that agriculture is the place to be, and agriculture is very critical, and agri-food systems are complex. We have many challenges, and solutions require systems approaches, out-of-the-box thinking. Our innovations should be productive, profitable, resilient, resource smart, nutrition smart, and climate smart. And focus should be on producing nutritious, safe, healthy food from existing farmland, without damaging our natural resources, but rebuilding our natural resources with climate resilience. And there are many available innovations. I just gave you 17 different examples, and all of these will require transdisciplinary and convergence of both biophysical and social sciences, and effective partnership with private and public sectors and farmer associations and farmers included, to make sure that our technologies are adopted and scaled at an appropriate level, which will have an influence on food security, nutrition security, climate security, and soil security. With that, this is my team which helped me do all the work in Kansas, and these are the people who have helped me. Again, I'm so glad that my mom and dad, Amma, Nana, and Akka are here. This is the first time they've been here, so I'm very excited. And this is a time to celebrate the successes which PJT-AU, PJT-SAU, ANGRA, and APAU has had it. And what a way to celebrate that we bring all the alumni of this fantastic 60 years of success of our university and give them a chance to interact and mingle and pave the path for the future 60 years or more. With that, thank you very much. And my dad always says, Sarve Jana Sukhino Bhavantu, Annadata Sukhi Bhava, Jai Hind, Jai Bharat, Jai Jawan, Jai Kisan. Thank you.